Okay, so the first part of the question is, you are supposed to find velocity and acceleration function. So we are supposed to differentiate st to get velocity function. Okay, so the first term, what is the derivative of negative 20t? Ashwindaran.
Sorry, miss, can you say that? Sorry, miss?
What is the derivative of negative 20t? You every time when I ask you, I definitely need to repeat. Can you tell me what is the derivative?
It'll still be this negative 20, right? Or no?
Okay. Continue, Ashwindaran. How to differentiate 4 plus 2t to the power half?
So will it still be 8 plus 18 and the same equation? Bracket 4.
Should I bring down the power?
Yes, miss?
What should I do to the power?
You should bring it down then
Minus 1.
oh, minus 1. Okay.
Ashwindaran.
Yes, miss.
Okay. You better do something about it, okay?
Okay, miss.
Miss Lo don't want to keep scolding
miss, yeah.
people. Okay. So cancel. So I got it as negative 20 plus 80 divided by square root of 4 plus 2t. Okay, so this will be meter per second. So if you want to draw the sign diagram, first of all, you have to find what is the value of t when velocity equal to 0. So you write down negative 20 plus 80 divided by square root of 4 plus 2t equal to 0. So this is your VT. So you bring the 20 over. So sometimes you have to know how to solve algebraically because the question may ask you show algebraically. So you have to learn both methods. So cross multiply. Okay, divide by 20. I got 4. Bring the square root over. So it becomes square. So the answer is 16. So 2t equal to 12. So t equal to 6. So now you got the sign diagram of VT. You have to do the sign diagram of VT. You have to go with the help of the graphic calculator to determine the sign. Start from 0 onward. Okay, what should I mark on the line? What should I mark on the line? Shinyi.
Yes,
Shinyi, what number should I mark on the line?
6.
Yeah, thank you. Okay, so how am I going to determine the sign? I use my graphic calculator. Okay, you call out your Y2. Yep. Okay, Shafiq, may I know what is the sign between 0 and 6?
Positive.
Positive. Then after 6?
Negative.
Negative. Okay, so I need someone to do some, this is not part of the question, so I need someone to do some interpretation for t between 0 for the first 6 seconds. The object is moving what? Okay. Christopher,
Yeah.
for during this period of time, the object is moving.
Right.
Yes, thank you. To the right. Okay. Then for the rest of the time, the object is moving to the left. At t equal to 6, what can you say about the motion of the object? Wen Cheng.
It reverses its direction.
Correct. It reverse its direction of motion. Other than that, what can I say? Other than say it's reverse its direction of motion, Wen Cheng, what else can I say?
Stop moving.
Yeah, it stop. So we call it momentarily at rest. You also can do it as, interpret it as momentarily. Did I spell it correct? Okay, you go and check the spelling. Momentarily at rest. Okay. So we also can interpret like that. So from the simple diagram, you must have all this in mind. Hand on up. So we are done with the velocity function and the velocity sign diagram. So whatever I bracket here is not part of the answer. The answer is from here right up to here. Okay, let's go to the acceleration function. So we have our VT as -20 plus 80 times 4 plus 2t to the power of -12. So we want to find acceleration, we must differentiate the velocity because acceleration is the rate of change of velocity. Okay, Bram, may I know what is the derivative for VT? Can I?
Yes, Miss. 80
80, thank you.
bracket -1/2
Good.
bracket 4 plus 2t to the power of -3/2.
Yeah, -1, correct?
Yeah.
Okay, so we have this. Here we cancel. Got 40. Yeah. So we get -40 over 4 plus 2t to the power of 3/2. Right?
Miss.
Hmm?
For the 80, you have to times 2
Why have to times 2?
because 4 plus 2t, the differentiation for.
Oh, yes. Just now we didn't do that.
Yeah.
I forgot to write that. Yeah. So, thank you. So you got 80 here, negative 80. Okay, now, so if I want to show that, okay, in this case, do you know that you can say that the velocity is always decreasing? Do you agree? Because t is greater than 0. Okay, 4 plus 2t is always greater than 0. So therefore, at, which is a negative 80, divided by a positive number, will be less than 0. Am I right? So this show that this is not part of the question also. Show that velocity is always decreasing. Okay, so the sign diagram for AT will go in this way. Negative. Right? So I've done with part 1. Yeah. Okay. So I'm going to go to part 2. Part 2 is to find the initial position. Yeah. Carol Rampa, what should I do? If I want to find initial position,
You should substitute 0.
what substitute what equal to 0 into what? You have to
Oh.
mention it clearly to me.
Okay, so S,
Yeah.
S bracket 0, because you sub it in.
Yeah.
Yeah.
Yeah. So do I need to substitute the value one by one?
Yeah.
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 Okay.
So
Or
it's,
you can use your scientific graphic calculator.
Mhm.
Can you
So-
get it the answer from your scientific calculator, graphic calculator?
Graphic. Yes.
How to get it? Can you tell me?
But I don't use graphic, miss. I use scientific.
How
But
can
no,
you
you can.
don't use graphic? Do you have a graphic calculator?
Yes.
So please use your graphic calculator.
Okay.
Just now I asked you to key all this into your graphic calculator. Did you do it?
Yeah, I did it.
Yeah, so now use your graphic calculator. Don't use your scientific.
Oh, okay.
That is much faster.
Okay.
Do you know how to use your graphic calculator to get the answer for this one?
Do you like sub in Y1 and then 0?
Yeah. So first of all, do you know how to call out Y1?
Yeah, I know.
Okay, good. That is good.
Do I say the answer, miss?
Yeah, just tell me the answer.
So it's 160.
160.
Yeah.
Sure?
Yeah.
Okay,
Because
let
you
me
sub. Yeah.
Is it 160, class?
Yes, Miss.
Yes, it's 160. Yes. I'm calculating. Okay, 160 meter. Okay, so Carol Rampa, do you like to help me to interpret this value?
Yeah, so it's negative 20 and then you
No,
bracket 0.
interpret this value. That means I want to know the meaning of this value. 160 meter, what does that mean in this context?
It means like is it the distance?
No,
Because it's meter. Oh,
no.
it's
So
a
I
distance
have
from
to put the word
oh,
initially. Why I need to put the word initially?
because it's from the
Because t
origin.
equal to no, because
Oh.
t equal to 0.
Oh,
Initially, continue.
160 meters is from the right. No, it's from the origin to the right.
Did we phrase it like that?
Ah,
Aha. Chunyi, can you help to interpret this value? Chunyi,
When
I write the word already initially already. Because I want to talk about the time.
when t equals to 0,
We don't say when t equal to 0, because when you say t equal to 0, people have to interpret what do you mean by t equal to 0. So when people ask you to interpret, you don't say when t equal to 0. You will use the word initially.
initially t equal to 0.
Why initially t equal to 0? Initially, the word means t equal to 0.
Oh.
You have to link between English and maths, okay, please. That's why a lot of people don't understand what are you writing or what am I writing is because they can't link. Maths is the language. So if I translate t equal to 0 into English, I have to use the word initially. Do you get me? Okay, how to interpret?
Initially, the object is 160 meter to the right of the origin.
Correct, just as simple as this. Initially, the object is 160 meter to the right of the origin. The origin is the fixed point, correct? If you don't want to say origin, you can say to the right of the fixed point on the straight line. So that is every number you calculated, you must know how to interpret. Even the question don't ask, as you practice, you must interpret. Do you get me? So now, if I look at the motion diagram, still remember yesterday we talked about motion diagram? Yeah, I mean a straight line. So this is the origin. So where is the object? 160 meter. This is the starting point. So this is the starting point. When I observe the motion of the object is here at the beginning. Or you say at the beginning. I can change the question to, okay, where is the object at the beginning? So you see, max, one word, t equal to 0. In English, you can translate it into a few different words. So you want to do well in maths, you must be able to do the translation. That's why I say maths is the simplest language. Okay, done? Okay, so part 3. Find part A, initial velocity of the object. Okay, what should I do for initial velocity, Amanda?
Substitute 0 to the VT function.
Yes, okay, so I put V0, correct?
Yes.
Okay, then I can use my graphic calculator straight away get the answer. So what is the answer?
20.
20. Is it? Amanda? 20.
Yes.
20 meter per second. Okay, so Amanda, if you don't mind, can you interpret this? Amanda?
Initially,
Good.
initially the object is
The object is, yes.
20.
When you see, Amanda, when you see velocity, correct, class, you straight away moving. Because velocity makes something move, correct? Initially, the object is
moving to the right
good. Is moving to the right, yes.
with the speed of 20 meter per second.
Thank you. Is moving to the right because it's positive, correct? With the speed of 20 meter per second. So I know it's moving to the right. So now I can draw my little car to the right. See or not? Hello? So every value you count for application, you must know how to interpret. Okay, let's look at part B. Okay, the velocity of the object when t equal to 16. What should I do? Yi Xuan. Yi Xuan. Yi Xuan.
Sub 16 to the VT function.
Okay, good. So what is your answer?
Negative 6.67 meter per second.
Okay, negative 6.67 meter per second. Okay, now my question is, if the question asks for exact value, then you have no choice for exact value. Then you have to substitute it manually. Are you clear? So that is something that you have to bear in mind. 4 plus 2 times 16. So is negative 20 plus 80 divided by 2 times 16 is 32. So square root of 36. Right? So square root of 36 is 6. So the exact value will be negative 20 plus 80 divided by 6. Yep. So this is 40, this is 3. So 60. So you got negative 20 divided by 3. So that's why you got 6.667. So this is the exact value. Please take note of that. Okay. Can you please interpret this one? Whosoever I called just now.
Object is moving to the left.
So should we say about the time? Either you can say at 16 seconds or after 16 seconds. Do you get me? So we try to specify the times first. Okay, after 16 seconds. So when I say after 16 seconds, I mean t equal to 16, okay? After 16 seconds, the object, yes, continue.
Is moving to the left with the speed
It's moving, yeah.
of 6.67 meter per second.
Good. It's moving to the left with the speed of 6.67 meter per second. Okay, you see? Can you? Okay, good. So that is how you interpret. So that means you know it reverses direction already. That means it goes somewhere here. Before 16 seconds, it reverses the direction already. Am I right? Okay, let's go to part 4. Okay, part 4. The question asks us to discuss the behavior of velocity. So we have to write down the velocity function first. The velocity function is -20 plus 80, and we put it as divide. Divide by 4 plus 2t. Okay, so now we want to discuss the behavior. So we have to write down as t approaches infinity. So next one, what must I write? 先he, 新he, 新现, 西现. What must I write? The next expression.
The 4 plus 2t to the power of 1/2.
Okay, correct. So I have to write down what happened to 4 plus 2t square root. It will approach
Infinity.
infinity. So next one, what must I write? Shafiq.
VT.
Can I straight? Yeah, you can straight away write VT, but before that, I think you have to do something first so that people understand.
Over
Yeah, 80.
80 over square root of 4 plus 2t.
Yes. Okay, so it will approach what, Shafiq?
0.
Yeah. Everyone, do you understand why it approach 0? Krishalini, you understand why it approach 0?
Yes, yes.
Yes, you understand, because 80 divided by infinity, so it's very, very small, correct? So then I go to VT, which is -20 plus 80 divided by square root of 4 plus 2t. It will approach, yeah, Krishalini, can you give me the answer? Krishalini, can you give me the answer?
-20.
Good. -20. So is this the lower limit or the upper limit? Is this the lower limit or the upper limit? Xingren.
Lower.
Lower limit, that means we have to write here from above. So that means I know that how I interpret. So this is a horizontal asymptote. So how I interpret this? I will say that the velocity will not go below -20 meter per second. That is the lowest velocity it can go. So that means when I get the velocity graph, correct? This is the horizontal asymptote. Yeah. It will not go below this. The velocity is always up here. The graph. Are you clear? So that's why they discuss the behavior. So when they say discuss the behavior, after you got this, actually you have to write down this statement. Then you have to write down this statement that, okay, the velocity of the object is always, if I want to say it is always more than negative 20 meter per second, I can do like that. So I have answered part 4. Are you clear? So the way you answer. Okay. So number 5, find the time and the position of the object when you reverse the direction. Okay. So for part 5, we can get the answer from part 1. From part 1. Vt equal to 0. T is equal to 6. Correct? So you can do like that in the exam. Okay, so T equal to 6. So now you want to find the position. So I have to put V as 6. Okay, can someone give me the answer? You have your scientific graphic calculator. Please give me the answer straight away. Okay, Nanidi Devi, can I get the answer for S6? You call out Y1, you key in the X as 6.
Yeah, I got 200.
Okay, I don't know the answer. Your friend have to, is it 200 meter?
Yes.
Yeah. So if they say find the time and the position when the object reverses direction, so the object reverses direction at t equal to after 6 seconds, and it is 20 meter, 200 meter to the right of the origin. So this is how I imagine. So now, just now we have our motion diagram, correct? Okay, I keep repeating it. The reason is because I want to show it. So here is 200. So you start from here. T equal to 0 is here. T equal to 6 is here. After 6 seconds, the car come here. Okay, it stop, then it reverse. See or not? That is how I imagine in my mind the motion diagram. Okay, good. Number 6. Okay, find the time when the speed of the object is increasing, correct? Still remember yesterday, I said if you want to talk about the speed, what should you do? Okay, I just want to test your memory. Yeah. Sebastian, what should I do first before I come to a conclusion for this question? Sebastian?
Is a look at the sign diagram
Sign diagram of what?
of VT.
There are so many sign diagrams, yes?
Look at the sign diagram of VT.
Is that enough? Are you in my class yesterday?
Yeah.
Yeah, is that enough? I just look at the VT sign diagram, is that enough?
And then you
Is that enough?
test the let the
Hey, hello, young man. When I say just look at the VT sign diagram, is that enough to determine the speed?
no, you have to look at the acceleration and see if the
Yeah, I
velocity
have
is
to
decreasing
not
or
look,
increasing.
not look. I have to,
Let equal 0.
yeah, let it. Okay, so this is negative. So for speed increasing, so which region should I choose? Sebastian, please.
I'm sorry, can you repeat?
To know increasing speed, which region should I choose? Now there are two regions here. Which region should I choose?
The negative region.
Why negative region? This one also negative region, what?
I know. So it's the same sign. So
Yes. So you have to say, you have to choose the region with the same sign for both VT and AT. Same sign. So this one is something that you must remember. So therefore, I make a conclusion. T greater than 6. So you see, it starts from 0, go to -1, go to -20, go to -30. You see, isn't it? The speed is increasing, but the velocity is decreasing. See or not? Okay, so this is a very important fact that you must remember. Can? Okay, now show that the velocity is always decreasing. So I show already just now. Okay, find the acceleration when t equal to 6 seconds. That one, I'm not going to do it. You have to know. The one is very straightforward. Okay, so number 9. Find the total distance traveled by the object in the first 16 seconds. So what should I do for number 9? What do you mean by first 16 seconds? What do you mean by first 16 seconds? Okay, Raisa.
When
What is the range for time?
0 is smaller or equals to t, and then 16 is greater than or equals to t.
Okay. So Raisa, if I want to find the total distance traveled within this period of time, what is the first question that I must ask myself?
Does the object stop moving?
Does the object stop during this period of time? Okay, so I have to ask this question, correct? Does the object stop during this period of time? So does it stop? Does it stop during this period of time from part 1? Okay, from part 1, can you tell me when does the object stop?
From part 1, it stops at the distance, is it?
No, stop. I want to when it stop.
At t0 at
Yeah, stop at
equals to
t equal to what?
0.
How can be t equal to 0? T equal to 0 is initial.
Oh, 16. T equals 16.
How can be t equal to 16? Stop moving means velocity equal to 0. From part 1, stop at t equal to t equal to
6.
Yes. Madeline?
T equals to 6.
Thank you. T equal to 6. So after I got all these, hold on, your friend asking something. Teacher, can you go back to the last slide where question 6? Okay, after when I end the class, I will give you all the slide, okay? I'll give you all the slide. Can I just finish up this one first? Okay, t equal to 6, okay? So now what should I do? The next step from here. Chokan. What are the things that I must find?
The
Chokan?
distance when
Distance.
t equals to 6.
Other than that?
The distance when t equals to 16.
Yeah, when t equal to 0, first of all. Okay, so just now we got it 160, correct? When t equal to 6, the displacement, not distance, please, the displacement is 200, am I right? Okay, when t equal to 16, what is the displacement? Can someone give me the answer? Yes, Chokan, can you give me the answer?
160.
100 and
60.
160.
Yes.
Yeah, go back to that. So that means I draw a motion diagram. Here is the origin. Here is start, 160. From here, go to 200. Then from 200, go back to 16. 160. So therefore, the total distance traveled will be equal to double this distance, correct? 200, take away 160 times 2. It happened to be like that for this case. So it's 80 meters. Hello, are you clear? So what do we call this diagram? Motion diagram. Okay. So kinematic, these are the important things that you have to take notes of. Are you clear? So these are all the applications. So you have to know. Okay, so I go. So your SAT 2, the question, the format will be like that. It's just I give you different function. So you better take an effort to memorize all the things. Or write down in your notes. Okay. First part, sure, I give you the displacement function, ask you to find the velocity function, ask you to draw the sign diagram. Okay. Acceleration function, draw the sign diagram. Okay, then you will follow by all the other questions. Depend on the function given, I can ask you to study. If there is a horizontal asymptote, we will give you the opportunity to explain that. Yeah. And for this question also, number 4, I can say, is there a limitation to the velocity? Instead of say, study the nature, I can say, is there a limitation to the velocity? So the moment I say, is there a limitation to the velocity? That means you have to study this. That is the rule. So question can be asked in this way also. So you see, I just need to use this example. I give you all the possible way to ask question. It means you have learned all the possible questions. It's just that now you need to go and practice how to solve it algebraically and so on. Yeah. Then this is a very important one. You want to study the changes of speed, you must have both velocity and acceleration sign diagram put on top of one another so that you can make a comparison of which region you should select. Okay. Then total distance travel. You must ask this question, find the important position, then draw the motion diagram, then find the total distance travel. So when we talk about max, it's like that. You must know the order first. Then you can be creative. If you can't even follow the order, don't talk about creativity. Creativity doesn't mean that you do things according to what you like. If you do things according to what you like, that is not called creativity, that is called ill discipline. Are you clear? A person who is creative, it must be first start with a person who can do things, follow the order, follow the rules first. If you do things according to what you like, that is called spoiled. That is not called creative. To be creative, you must have a certain extent of discipline. Are you clear? Okay, so class, I hope through these two examples, you have a clear idea of what do you mean by kinematic. So it's the relationship between y, dy dx, and d2y over dx squared. But this put in the context of displacement, velocity, and acceleration. Got it? I can even ask you, when is the displacement decreasing at the fastest rate? That means acceleration equal to 0. Am I right? So that comes your creativity already. That will make a difference why some people can get A+, some people cannot. Got it? Okay, thank you, class.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss.
Please
Bye,
do
Miss.
your exercise.
Okay.